Welcome back to Cypress Academy Wicked Wi-Fi 101. Chapter 6 has been all about how you exchange data on the internet. I showed you how to use sockets. Then we talked about how encryption works and how to prevent man-in-the-middle attacks. In the final video for this chapter, I will show you how to modify the non-secure WWEP client program from earlier to include security, specifically transport layer security. Let's get started. The first step is to copy the O2 client project into a new project called O3 Secure Client. As always, don't forget to modify the make target, the file names, and the makefile itself. The first step in the process of modifying the original project is to copy my file WWEP cert.pem into the Resources Certificates directory. The file WWEP cert.pem is a self-signed certificate that I created by running OpenSSL, just like this. You can find this file as it's included in the GitHub site for this project. This certificate is used for the more secure version of the WWEP server, and it will support a secure TLS socket. The next step is to add the certificate keyword to my makefile with the path to the WWEP server's PM file. This will cause the certificate to be inserted into my DCT. Now I need to modify the C file. At the beginning of the application start function, I want to read the secure WWEP server's certificate out of the DCT by calling WICED DCT readlock. Then I call the function WICED TLS init root CA certificates. I showed this function earlier, but I didn't talk about it. What this function does is add the certificate to the list of certificates that WICED uses to verify secure TLS sockets. In our case, there will only be one certificate, but you could have multiple certificates. For instance, if you think about a web browser, it may have hundreds of root certificates built into it. Obviously, this is not possible on a smallish IoT device, so you should think carefully about getting only the root certificates you need in order to safely connect and build your program. Once you have registered the server root certificate using WICED TLS init root CA certificates, WICED will then automatically verify all TLS connections using that certificate. The last step in fixing the non-secure WWEP client program to be secure is to modify the send data function. Remember from the earlier video that each time the button is pressed, the send data function is called. That function opens up a socket, formats the data, sends the data, reads the response, then closes the connection. For us to make a secure connection, we will make two small modifications to that function. Specifically, after the socket is bound with WICED TCP bind, I will create and initialize a security context by calling WICED TLS init context. Then I will call WICED TCP enable TLS, which will automatically make WICED open up a secure socket connection when I call WICED TCP connect. Remember that to get a secure socket going, you have to exchange certificates, verify them, and do the symmetric key exchange. The nice thing about WICED is that you don't need to think about any of that, as WICED does it automatically for you. Great. That's it for this chapter 6. Don't forget that you can look at my textbook that goes through all of these videos and review the actual projects on our website. In the next chapter, we will start digging into the important web protocols, including HTTP, MQTT, CoAP, and AMQP. You can post your comments and questions in our Wi-Fi developer community, or as always, you're welcome to email me at alan_hawes@cypress.com or tweet me at AskIoTExpert. Thank you.